The complexity of even the simplest life forms is one of the reasons why many scientists are becoming increasingly dissatisfied with the evolutionary explanation, with its reliance upon pure, unguided chance. There's good reason for scientists to question the power of chance. Take a look at this simple demonstration. You see what I mean. Now, here are 3 blocks, numbered 1, 2, 3. There are 6 possible combinations of these 3 numbers. Now, I'll put the blocks into this box and shake it up. Now, if I were to take out the blocks one at a time, what are my chances of taking them out in numerical order? Well, I can expect to draw out the numbers 1, 2, and 3 in that order on an average of once in every 6 attempts. Now, here are 2 more blocks, numbered 4 and 5. I'll add them to the 3 others in the box. Now, there are 120 possible combinations. The law of averages tells me that I can expect to pull out blocks numbered 1, 2, 3, 4, and 5 in that order on the average of once in every 120 tries. Now, look, here are blocks numbered 6 through 10. I'll put them in the box with the others. My chance of picking out all 10 blocks in numerical order is less than 1 in 3.5 million. Well, let me put that in perspective. If I put myself on a schedule and worked at this game day and night, pulling out all 10 blocks one at a time every 15 seconds, I could expect to win this game on the average of about once every 18 months. What if I doubled my quantity of sequentially numbered blocks to 20? How long should I expect to work at this game to get all 20 out of the box in order? Now, let's suppose that I could play at blinding speed and get all 20 blocks out in just 1 second, then do it again the next second and every second thereafter. Now, the law of averages says that I can expect to get the 20 blocks out of the box in order at the rate of once every 77 billion years. This little numbers game is nothing compared to the intricate complexity of even the simplest bits of matter. Physiologist and author Pierre Lecontenue, in his book Human Destiny, estimated the chance of forming a 2,000 atom protein molecule as something like 1 in 10 to the 321st power. There's really no good way to express that number. It's incomprehensible. Find yourself a large sheet of paper. Write 10 followed by 320 zeros. Now listen to what Lecontenue says.
Events which need an infinitely longer time than the estimated duration of the Earth in order to have one chance on the average to manifest themselves can, it would seem, be considered as impossible in the human sense.
This chunk of coal is about 70% carbon by volume. Carbon is essential to all organic life, and it's the 4th most common element in the universe. Yet this very ordinary element is extremely complex. In order for it to be produced naturally, 3 helium nuclei must combine to form a single carbon nucleus.
But we have found that the conditions needed for that to happen are really very precise. In other words, that if the balance of forces in the atomic nucleus were very slightly different, that reaction would not be able to take place in order to form enough carbon to be of any significance. Men who discovered this, the way in which this reaction takes place to form carbon, and who found the conditions that were necessary for it to take place was Fred Hoyle, who is one of the great astrophysicists and cosmologists of this century. Hoyle was very skeptical about religion. At the time, at least, he was an atheist.
Some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common-sense interpretation of the facts suggests that a superintellect has monkeyed with physics as well as with chemistry and biology. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question.